The sun isn't just a glowing ball in the sky, it's a cosmic inferno, powerful enough to create and destroy entire worlds. Every second it produces more energy than humanity has consumed in all of history. But what if I told you the sun is slowly killing itself, burning through its own life force in a desperate bid to survive? How does it pull off this fiery balancing act, and what happens when it inevitably loses? Let's uncover the jaw-dropping physics of the sun, and why it's the most astonishing machine in the universe. Imagine a colossal sphere so massive it holds 99.86% of all the matter in the solar system. The sun is no ordinary star. It's a celestial powerhouse fueled by a process so intense, it's as if 10 billion nuclear bombs were detonating every second at its core. At its heart, the sun isn't just a sphere of fire. It's a high-pressure cauldron of hydrogen and helium, constantly tearing its own atoms apart in temperatures hotter than the surface of a star like Sirius. Its gravitational pull is so immense it holds planets, moons, asteroids, and comets in perfect orbit. Without the sun, Earth would be a frozen wasteland, incapable of sustaining life. But as awe-inspiring as the sun is, its true genius lies in what happens deep beneath its surface. At the very center of the sun lies its core, a hellish region where the temperature reaches 15 million degrees Celsius. The pressure here is so intense that hydrogen atoms smash into one another, fusing into helium and unleashing a torrent of energy in the process. This is nuclear fusion, the same reaction that powers hydrogen bombs, but on a scale that makes humanity's most powerful weapons look like firecrackers. The energy released by this process is unimaginable. Every second, the sun converts 600 million tons of hydrogen into helium, and in doing so, it loses 4 million tons of its own mass, converted entirely into energy. That energy takes tens of thousands of years to fight its way through the sun's dense interior before it escapes into space as sunlight. Think about this for a second. The sunlight warming your face today began its journey before humans even learned to write, and yet, for all its brilliance, the sun is engaged in a constant battle to keep itself alive. The sun's very existence is a war between opposing forces. Gravity, relentless and unforgiving, constantly tries to crush the sun inward, pulling it toward its core. On the other hand, the immense pressure created by the energy of nuclear fusion pushes outward, trying to rip the sun apart. The delicate equilibrium between these forces is what keeps the sun stable. But this balance is fragile. If the fusion process slows, gravity could win, causing the sun to collapse. If fusion accelerates, the sun could expand uncontrollably, possibly ending life on Earth as we know it. This tightrope walk between life and destruction has lasted for 4.6 billion years, but it won't last forever. If you think the sun's surface is a peaceful, glowing sphere, think again. The sun's outer layer is a chaotic battlefield of magnetic forces, creating phenomena so powerful they can affect life here on Earth. Sunspots, massive dark regions, are caused by intense magnetic activity. These spots are cooler than the surrounding areas, but they're still thousands of degrees hotter than anything on our planet. Then there are solar flares, explosive bursts of energy that can release as much power as 1 billion nuclear bombs in minutes. Even more dramatic are coronal mass ejections, which hurl billions of tons of charged particles into space at speeds of up to 1 million miles per hour. These events can wreak havoc on Earth, disrupting satellites, power grids, and communication systems. Every 11 years the sun goes through a solar cycle, peaking in activity with storms and flares that remind us just how alive and unpredictable it truly is. The sun is currently in its prime, burning through its hydrogen reserves in what scientists call the main sequence stage of its life. But like all stars, the sun is mortal. In about 5 billion years it will run out of hydrogen fuel, and its core will begin to collapse under the weight of gravity. This will trigger a series of catastrophic events. As the core contracts, the outer layers of the sun will expand, turning it into a red giant. During this phase, the sun will grow so large that it could engulf Mercury, Venus, and perhaps even Earth. Imagine the sun swelling to 200 times its current size, its fiery surface brushing against what's left of our world. But this isn't the end. After the red giant phase, the sun will shed its outer layers, leaving behind a glowing shell of gas known as a planetary nebula. At its core, all that will remain is a white dwarf, a dense, Earth-sized remnant of what was once the most powerful force in the solar system. Slowly, over trillions of years, the white dwarf will cool and fade into darkness, becoming a black dwarf. The sun, the giver of life, will one day be nothing more than a cold, silent cinder, but its death won't be in vain. The elements forged in its core will seed the next generation of stars and planets, continuing the cosmic cycle of creation and destruction. The sun is more than just a star. It's the engine that powers life on Earth, a force of nature so immense and complex that even our best scientists are still unraveling its mysteries. From the awe-inspiring process of nuclear fusion to the explosive beauty of solar flares, the sun is a testament to the power of physics and the fragility of existence. If you found this journey into the heart of our star as incredible as I did, make sure to share this video with someone who loves space and science. And don't forget to subscribe for more mind-blowing explorations of the universe. The sun may shine for billions of years, but our curiosity burns brighter every day.